Good morning, students. Today we're going to review for our final days of full reviews of pre-algebra 8th grade math, graphing lines, talking about functions on the next page, and then solving proportions that you started in 7th grade. Okay. After this, we will get started into the Algebra 1 curriculum. So again, this is a review. All right. Determine whether each equation is a linear equation. Okay, so we get a breakdown. You got to learn your vocabulary. You've been taught it before, but as I question you in class, oftentimes most of you cannot answer it because you've chosen not to memorize your math vocabulary. Even you're going to see this and hear the same thing year after year after year after year, and even into college. Same vocabularies that we use. And of course, you know I offer extra credit for defining vocab words throughout the year. So linear. Obviously, you should be able to tell from the first four letters, it means it's a line. So whenever you see linear, just think the first four letters, you got a line. Equation must have an equal sign in it. Okay, so we have to determine whether these equations will graph into a line or not. And then it says if the equation is linear, so if the answer is yes, rewrite it in the form ax plus by equals c. And you should be familiar with that as well. That is called standard form. So you need to know that vocab word as well. You should already know it. Okay, it's on the pre-algebra cheat sheet that I've given you before, already earlier in the year. Now, the one thing they haven't told you and they expect you to know is the conditions for the coefficients. Remember, coefficient is the number in front of the variable. So A and B are called coefficients. C is called the constant. So these are coefficients. And this one here is a constant, any number by itself. I've already even asked this for extra credit in class already this year. Okay, so the A, B, and C, and oftentimes it may be capitalized, it may not be. So A, B, and C are integers. Of course, you should know what integers are, positive and negative whole numbers 0, 1, 2, 3, etc. And the last condition is A must be greater than 0. Now, we'll get into graphing lines in the second semester here. So all this will come back true. And so obviously I'll be quizzing you over all this vocab. And I'll say, look, we went over it in the first week of school or first 2 weeks of school. So again, those, and of course you didn't last year and the year before. At least last year for sure. Okay, so now how do I determine from looking at an equation whether it is going to graph into a line or not? So I'm erasing this so you can pause it if you need to or rewind it. I look at the x and y exponents. X and y exponents. So again, you should know what an exponent is. The number up top there, it's called the exponent. That's a 2 there. Okay. So the x and y exponents must, dang it, scroll down by accident, screen is sensitive, must both, dang it, spell right, come on, erase, both be 1. Okay, so that's the first condition. Okay, x and y exponents must both be 1. You may have, come on, only, dang, it's sensitive, eraser. You may have only an x or y. on, in the equation. Okay, so that means you don't have to have both. You might read this number 1 and saying, oh, x and y, x and y must both be 1, so I must have to have an x or y. No, that's why I have it in parentheses. You may have only an x or a y in the equation. You don't have to have both. We look at number 3, it only has a y. That's the only one that only has 1. Okay, so, and that exponent on it is a 1. Remember, if there's nothing there, it means it's a 1. So yes, that is a linear equation. The second condition is the x and y must be in their own term. Okay, so you know the math vocabulary word term. A term is separated by an expression that's separated by plus or minus signs. Okay, so if we looked at number 1, for example, they both have a 1 on them, but the problem is the x and the y aren't in their own term. This is one term right here. So this has both an x and y in one term. It cannot happen. It has to be in their own terms. Okay, such as 4, 5, number 6, 3, they're all in their own terms. 2 is, well, but 2, remember, don't forget that has a 2 as an exponent, so it wipes that out. It has to be an exponent of 1. Okay, so you need to know these are the conditions that make the exponent 1. And when I say 1, that means 1 in the numerator. So there isn't 1 here, but say, for example, I had 1 over x to the negative 1. And you say, well, that exponent on the x is not a 1. It's a negative 1. Well, the problem is I got to first turn it into a positive. How do you turn a negative exponent into a positive? You do the reciprocal, which means if it's in the denominator, it moves up to the numerator, and now that becomes positive, so it really says x to the first, and now it satisfies our condition. So if there was negative exponent, a negative 1 exponent in the denominator, that's the same as a positive 1 exponent in the numerator, and so it satisfies the condition. Now, we don't have that example here. You're going to see that like in an Algebra 2. You might see it later in Algebra 1, but for sure in an Algebra 2 book. All right, so that takes care of the top part there. Now we graph equations. So notice 7, 8, 9, and 10 are almost all in standard form. 7 and 8 are in standard form because remember ax plus by equals c, and they're all integers, and a has to be positive. There's a 1 there, and there's a 3. So 7 and 8 are in standard form. 9 and 10 are almost in standard form, except for the problem is the coefficients are not integers, but I can easily change them into integers by multiplying by the common denominator to clear the fractions. So I'll do one of each. Okay, so the 2 easiest points, write it down, the 2, because you only need 2 points to create a line. So the 2 easiest points to plot in standard form. And of course, I will ask this over and over, and your middle school teacher should have taught you this as well. The 2 easiest points to plot in standard form are the x and y intercepts. Okay, so now you have to know how to calculate the x and y intercepts. And what is an x and y intercept? X-intercept means where it crosses the x-axis. Y-intercept, where it crosses the y-axis. So you're going to get a point on each axis. And then you just use your ruler and connect them. Okay, so we're going to find the point on the x-axis where the line crosses and the point on the y-axis where the line crosses. Plot those 2 points, and then you have your line. So we'll go ahead and do number 7. I'm going to go ahead and erase that. So if I look at the x-intercept, That means the x-axis. What point, which coordinate, which coordinate on here, and I'm just picking the integer ones, is the same for every one of those points? Is the x-coordinate the same or the y-coordinate the same, and what is it? If I plotted every one of those points, the y-coordinate is always 0. So that's set. So that's what I do to find the x-intercept. I plug in y equals 0 and solve for x. So that automatically wipes out that term and you get x equals 6. So 6 comma 0 is the x-intercept. Now for the y-intercept, which coordinate is 0 every time along here? The x-coordinate is, and the y-coordinate changes. So now that means plug in 0 for the x and solve for y. So if 0 is there, I have negative 3y equals 6, so y equals negative 2. That's easy to do in your head. So 6, 0, and 0, negative 2. And then I take my ruler and connect them. Okay, and I can adjust that right like that. And then I can just add the arrows on. Okay, and there's that line. Now, your teacher might have gone ahead and told you and taught you, okay, we're going to solve for y every time and put in slope-intercept form and then graph the y-intercept and the slope. You can do that. That's a legal way. But the quickest way, with the least amount of errors, is that right there, the x and y-intercepts. I've told you all along, and I'll keep reminding you throughout the year, you do not have to do it my way, the smarter way. You can choose any way you want. You can do it longer ways, increase your chance for error. I don't have a problem as long as you do the right steps and get therefore the right answer. Okay, so there's that one. And let's look at number 9 and 10. They have fractions in it. I know you don't like working with fractions, so we're going to get rid of the fractions. So I'm going to multiply the entire equation by the common denominator of 6. 3 goes into 6 and 6 goes into 6. You've done this for years, since about 4th grade, dealing with fractions, getting a common denominator, also called the least common multiple. Okay, so I multiply 6 through here. Now that becomes a problem for a lot of kids as well because they don't know how to multiply fractions still from elementary school. But I'm going to show you a short, quick, simple way to do it. Okay, so memorize it. So it'll save you a lot of time. I take that number out front, 6, divide it by that denominator. 3. What's 6 divided by 3? 2. Then I multiply, so I'm dividing that one, and then I multiply by the numerator. So I have 2 times 1 is 2, and then I have the x there. Minus sign, 6 divided by 6 is 1, times 1 is 1. Y equals, and 6 times 0 is 0. Now I have it in standard form, nice and easy. X and y intercepts, x-intercept. Okay, if that means y is 0, and I get 2x equals 0, x is 0. Y-intercept, I also get 0, because x is 0, and then y is also 0. So notice that's the same point, 0, 0. I need 2 points. So I can come up with another point on my own by plugging into either the x or y and solving for the other, or very simply, I could just move that across the negative 1y. When I move any term across the equal sign, I do the opposite operation. So add 1y across, and I get y equals 2x. Or you can say 2x plus 0, because there's my y-intercept of 0. Now it is in slope-intercept form, and of course then the slope, I always write as a fraction, 2 over 1. And remember, slope is change in y over change in x. So the y direction is either up or down, depending if it's positive or negative. X left or right, depending if it's positive or negative. Since they're both positive, the y positive direction is up. The x direction positive is to the right. So I go up 2, right 1. Up 2, right 1. There's my line. Okay. So now you've seen it put in slope-intercept form. You always put your arrows on it. Hopefully your middle school teachers taught you that. So slope is directions, gives you directions to other points. It's not a point itself. It gives you directions to other points. That's why we have the arrows there. It gives me directions to get to another point. I started at a point already on the line, 0, 0. So you don't always start at 0, 0. When you use slope, you start at a point that's already on the line, and then you follow those directions. Okay, and then go ahead and connect those. Okay, and oops, there's your line. All right, next page. Functions. Determine whether each relation is a function. A relation is a set of points, is a function. So the definition of function you need to know. Function. We're going to give it verbally and graphically. Function. So this right here, I can just do it graphically, but I'm going to still give you the verbal answer. So it's a set of points. Do they have a set of points down here? Yeah, they do right here. That you'll use that one. Function. For every x, meaning x coordinate, there is only one y coordinate. Okay? And graphically, let's change the color. Graphically, it must pass the vertical line test. Okay. So what's the vertical line test? The vertical line test is if I draw a vertical line anywhere, it will only go through one point in that relation in all those set of points. So very simply, right here, that fails because it goes through 2 points right there. So it can't go through 2 points. I draw a vertical line, only can go through one. Or I draw a vertical line anywhere. So that fails. Determine whether it's not. This answer would be no. Okay. Obviously, if I have a vertical line itself, it fails. Now, if I look right here, this passes. If I draw a vertical line anywhere, it's only going to hit one time through any of this. So that's a yes. Okay. So that's using the graphics, graphically, the vertical line test. With down here, all I look for, another way of saying for every x, there's only one y, no repeat x's. That's a simple way to think of it. So do I have any repeat x's right there? No. So therefore, it's automatically a function. Okay. Do I have any repeat x's here? Oh yeah, every one. I didn't have to have every one. If I had one repeat x, it fails. Okay. Now, from an equation. Okay. Do I want to deal with this now? No. Can't believe they're putting this Algebra 1. I'll let you, we'll go ahead and skip this section. This is better for Algebra 2. I have to explain too much. And you can't graph these equations, most of them, quickly. Actually 14, 12, and 16. So I'm not gonna go through that. You actually do that in geometry and Algebra 2. All right, bottom part here. If the f of x, that's called function notation. Function notation. Okay. The letter on the outside, that's called the name of the function. Name of function. So it's the f function. Whereas this is the g function. Okay. The variable on the inside of the parentheses is called the independent variable, which is what would be graphed on the x-axis, independent variable, which means it has to be the exact same variable that's on the other side. So I can't have the f of y equals 2x minus 6. If it's f of y, it would have to be 2y minus 6. Okay, it's got to be the exact same. Okay, so what the f of 2 means, it says for every x, plug in 2 in the f functions, not in the g function. It says f of 2. It doesn't say the g of 2, so it only wants it in the f function. It's called function notation. It's almost the same as y equals 2x minus 6. Okay? The difference is, if it's in function notation, as it is here, that guarantees when if I was to graph an equation, if it was given to me, if I was to graph that equation and y equals 2x minus 6, it guarantees me that's going to pass the vertical line test. Remember how we tested up here? Is it a function or not? If the answer is yes, that means I could write that equation in function notation. If the answer is no, I could not write it in function notation. So since these equations are given to me in function notation, that means if I just graph those equations, they would graph and pass the vertical line test. So that's the huge benefit you get. So you'd be able to know when you graphed it, if you graphed it right. So if I graphed one of these and I graphed it and I came out like this, I know I'm wrong because it fails the vertical line test. All those places, infinite places. So that would be a wrong graph if I thought that was the right graph. See, whereas y equals doesn't tell me anything, whether it's a function or not. So that's the huge benefit of function notation. So again, this just says plug 2 in for the x. So I have the f of 2 equals 2 times 2, because I'm plugging in for the x, minus 6. So the f of 2 equals 4 minus 6, negative 2. Okay, so that's what you'd write. The f of 2 equals negative 2. You show you work by plugging it in, and you can do that basic math in your head. Okay, so that's what you're going to do for rest right there. All right, now solve proportions. You've been doing this since 7th grade. Okay, there's multiple ways to solve proportions. Hopefully your middle school teacher has taught you shortcuts. If not, you'll learn them here. Okay, one way that always works is if I cross multiply. You've seen the butterfly, I often call it the butterfly. Okay, cross multiply, set them equal to each other. So whenever I ask how do you solve all proportions, you could say cross multiply, set them equal to each other, and then solve. So I cross multiply, I get 2x equals, I think that's 3 up there, so 4 times 3. Now, you could put 12, sorry, 4 times 3, 12. Notice I left it as 4 times 3 because I'm going to help you to reduce quicker. And we'll use this later. Well, you'll learn how to do this in geometry. We're talking about square roots as well. So I know I'm going to have to divide by 2 on both sides. Divide by 2. Well, now I can do this 4 divided by 2 right here. That 2 cancels out. 4 2 times. And so I have 2 times 3 is 6. Okay, which is what you get when you did 12 divided by 2. But that's easy with small numbers, but when it gets bigger numbers, it's much easier to cancel out like that. Okay, instead of multiplying together. All right, let's go down here and I'll show you a shortcut. Number 10. I could cross multiply. Now, don't forget, if you do that, you need to put parentheses around that because there's more than one term. Your middle school teacher should have taught you that. Whenever there's more than one term in either the numerator or denominator, you must put parentheses around those so you do not forget to distribute. But a shortcut. Does 4 go directly into 12? Yes, it does. Times 3. So that means if I take this number, times it by 3, I did it by 3 in the denominator down there, so it must be by 3 up here, it must equal 6. So now I have 3 times that quantity, x plus 1, must equal 6. Now here's another shortcut. Most of your middle school teachers would tell you to go ahead and distribute. You can do that, okay, but some people will blow it on that, and it's actually longer. But this has 3 times the quantity x plus 1. Remember, whenever you say the word quantity, that means whatever comes next is inside parentheses. The opposite of multiplication is division. So I could divide right away. And now I just have x plus 1 equals 2. What plus 1 equals 2? 1 plus 1 equals 2. Okay, much simpler than doing the 3x plus 3, distributing across, then subtracting the 3 across, and then dividing. More steps, more chance for error. Okay, and of course I could always test my answer by plugging back into there. What is 1 plus 1? 2. What's 2 divided by 4? 1/2. What is 6 divided by 12? 1/2. So they're equal. Remember, you can always plug. That's the nice thing about equations. You can always plug your answer back in to test if it works. Okay, let's go down here and do one last one down here. Okay, let's say number 22. So I see I have two terms there, so I must have parentheses. I'm going to go ahead and need to cross multiply. So I have 3 times the quantity x minus 2 equals -4 times the quantity x plus 5. Now, it's not going to do me any good to divide by 3 over -4 on both sides because they don't divide evenly. So I'm not going to do that. So I'm going to distribute. 3x minus 6 equals -4x minus 20. Again, now the smarter way of doing things, it doesn't really matter what side you bring the x's to, but you want to be smarter, which means I want when I subtract it, I want to, or move it across the other side, I want it to be a positive answer. So I take the smaller coefficient, obviously -4 is smaller than +3. I always take the smaller variable over to the bigger variable side. So I make it a positive. So how do I move any term across? Do the opposite operation. So I'm adding 4x to both sides. Well, since I'm moving the variables to the left, the constants, or constant in this case 1, must go to the right. So what's the opposite of -6? +6. That's gone. So now I have 7x, 3 plus 4x, 3x plus 4x is 7x, and 6 minus 20 is -14. Last step, divide by -7 and simplify down to -2. And there's my answer. All right, that'll do it. 27 minutes. Cover all 3 lessons there. Review lessons.